All right, number 5 says the volume of sodas in quart soda bottles are normally distributed. Okay, normally distributed with a mean of 32.3 and a standard deviation of 1.2. Okay, so I have a normal distribution. So it looks like this. Remember, your mean goes in the middle, 32.3. And I'm going to write the standard deviation off to the side just so I see it. Okay, we're looking for what is the probability that the volume of soda in a randomly selected bottle will be less than 32. Okay, well, about here is 32. We are looking for less than that, so I'm looking for the area to the left. Okay, so the first thing I need to do is I'm going to be able to use this z-score table because you've got area right here, and that is linked to a z-score. So the first thing I need to find is my z-score. So we're going to use that formula. Z is equal to x minus the mean divided by standard deviation. So that's going to be, our x is 32 minus our mean, 32.3, divided by standard deviation of 1.2. So I'm going to go out to 2 decimal places, and that's going to give me negative 0.25 for my z-score. Okay, which it should be negative because here's our mean, and we're looking on this side. So all my z-scores will be negative over here. All my z-scores will be positive over here. Okay, so I need to go back to my chart. Go to the negative side. Okay, I need negative 0.2. Okay, there's 0.2. And then I need 0.05. So here's 0.05 right here. Okay, so where those intersect, right there. Okay, so this is the area to the left of what you were looking for. Okay, what we're looking for was 32. The area to the left of that was 0.4013. So the probability that x is less than 32 is equal to 0.4013. That's your final answer. 14, if a normal distribution, okay, that's important, has a mean of 18 and a standard deviation of 1.2, what value, or you could say what x value, is at the 80th percentile? Okay, hint, bottom 80%. Okay, so here's my normal distribution. My mean is 18. My standard deviation is 1.2. We're looking for the bottom 80. Okay, so if I looked, so this would be the bottom over here. This would be the top because it goes from 0% down here up to 100% up here. Okay, so if I look right in the middle, that's going to be 50%. Get rid of that. So we're looking for 80%, so it's about here. Okay, so all of this would have 80%. I'm going to get that out of percentage, so that's 0.80. So all of this area right here has an area of 0.80. Okay, so since we're not looking for a probability or the area, since they already gave us the area, they said we're finding an x value, we need to use x is equal to the z-score times standard deviation plus our mean. Well, I've got these two. The only thing I need to get is a z-score, which is always attached to an area, which our area is 0.80. So what we need to do is we need to go back to our z-score table, and we need to find somewhere in here, inside here. 0.80 or something really close to it. Okay, so there's 0.8 right there. See if we can... Okay, so I see this one right here, this one, and this one. So what I would do is, to make absolutely sure you're getting the closest one, is I would take the 0.8023 minus what you're trying to get, which is 0.80. So that comes out to be, let's see, 0.0023. Compare that with 0.08 minus 0.7995. And what that gets you is, was it 995? 0.0005. And then last one, 0.80 minus 0.7967. And what that will get you is 0.0033. And whichever one of these is the smallest number, that means those two numbers are the closest. So since this is the smallest number, these two, the 0.8 and the 0.7995, those two are the closest. So that's the one I need to use. So this one right here. Okay, now I need to get my z-score. So first go out here, grab that 0.8, and then come back over here, grab that 0.04. If you add those two, that gives you 0.84, and that's our z-score that we need to use. Okay, so right over here, our z-score is 0.84. Now I can plug everything in here. So 0.84 times 1.2 plus 18. So x should be equal to 19. And there's your final answer. First time at McBurger fast food restaurant allows or follows a normal distribution with a mean of 5 minutes and a standard deviation of 1 minute. The restaurant's policy is that if a customer is not served within a maximum time period, they will not be charged for the food ordered. The management wishes to provide this incentive program to at most 10% of customers. So they want 10% of customers to not be charged for the food order. The maximum guaranteed waiting time should be set at... Okay, so we're looking for the maximum guaranteed waiting time. Since waiting time is what we're looking for, this is really just saying find an x value. Okay, so we've got a normal distribution. We've got a mean of 5 and a standard deviation of 1. We want at most 10%, okay? So if this is the starting waiting time here. So they start here. They keep waiting, they keep waiting, they keep waiting. They want to know what is the max amount of time we should allow ourselves, and then we should say, okay, we're not going to charge you for the food because you've waited too long. So say it's about here. This is the max waiting time. Because after this time right here, then you're going to get the food for free. And they only want 10% of the customers to get the food for free. So that means this over here, starting at the max waiting time and going this direction, all these people will get the food for free. Okay? So this over here is 10%. I'm going to go ahead and get it out of percentage. So that would just be 0.1. 0.1. Okay? So I said we're looking for an x value, so we need to use this formula right here. And I've already got standard deviation and mean. I need to find a z-score. So it's just like 14. But notice on this right here, it's always from the left of what you're looking at. What they've given us is the information to the right. Okay? If you look at the area under the entire curve, that's going to be equal to 1. So to get the area to the left, 1 minus 0.1, which is 0.9. This is the area that you need to look for within that table. Okay, so we'll go back here. Okay, so I'm going to look in the middle here because all this is area or probability. That's the same thing for continuous distribution, which is what the normal distribution is. So I need to find something equal to 0.90 or something really close to it. So I see 0.90s here. Okay, and if I keep on going, let's see. Looks like this one would be the closest to 0.90. Okay, and you could do the same thing, 0.90 minus this one, 0.9015 minus 0.9, and 0.90 minus 0.8980, and see which one would have the smallest number, and it will be this one right here. Okay, so that z-score is 1.2. Grab that last one, 8. Okay, that's our z-score. Okay, so x is equal to 1.28 times 1 plus 5. So that would be 6.28. And that is your maximum waiting time. 19. For which of the following binomial experiments could have a normal approximation be applied? So for something to go from a binomial distribution to a normal distribution, remember you have to check two things. Number one, n times p is greater than 5, and number 2, n times q is greater than 5. When you've got both of these, then you can say, okay, it's not binomial anymore, it looks more like a normal distribution. Okay, and remember, p is equal to, q is equal to 1 minus p. Okay, so you would go through, say, this first one right here. So there's your n times your p. So you take 10 times 0.5, get that number. And then you could find q, so 1 minus 0.5. So q would be 0.5. So you take n times q, and you would get 10 times 0.5, which both of these come out to 5, which is not greater than 5. Okay, it's equal to 5, so it can't be the first one. And you do that for every single one of them. So for D, if n is 20 and p is 0.3, so p is equal to, keep doing that. Q is equal to 1 minus p, or q is equal to 1 minus 0.3. So q is 0.7. So n times p would be 20 times 0.3, and then you would have n times q, which is 20 times 0.7. Find a number for both of those. So this would be 6 and this would be 14. Since both of these are greater than 5, okay, so this right here, when you have n is 20 and your probability of success, or p, is 0.3, that's when both of them are greater than 5, which means this binomial distribution now really looks like a normal distribution. And all of these are going to fail. They're going to be less than 5 for both of them. And that's it.